Yours, welcome aboard to this special session. We are in the Nurture series, and Nurture series is for all the 11th standard students, also for the dropper and the 12th standard students who want to revise their 11th standard topics. Today is lecture number 1 of fluid mechanics, and this is your captain, this is your master teacher Shreyas, and I'm going live from Barometer Manometer. So welcome aboard to this special session, and this is a part of your long-term series on your favorite channel JEE Enthuse. So let me just quickly tell you what we are going to do today, and then we are going to start the session. So in this lecture number 1 of fluid mechanics, we are going to talk about what is pressure, what is hydrostatic pressure, how to calculate variations of pressure with height and depth, and the gradient. We are going to also talk about Pascal's law and its beautiful application. And then we are going to go to two very special instruments called barometer and manometer, see their working and their variations. And then yes, we are going to go to force on the walls of container. And also I'm going to give you homework questions. All of this with me, Shreyas, your physics master teacher at Vedantu. Hello everyone, how is everyone doing? Hi Aisha, Madhav, Roshni, good evening. Dakshin, Ramya, Madhav, Nivegi, welcome aboard. Vicky, Vivek. So this session is for all 11th and 12th standard students as well, and I'm pretty sure most of you would have completed your term 1 examination, and if you haven't completed it yet, don't worry. We need to start with the term 2 syllabus of your 11th standard because we can't keep waiting, number 1, and number 2, we are preparing for JEE, remember that, alright? And also thanks a lot for hitting that subscribe button, and also thanks a lot for smashing that like button down there. Good evening everyone. Yep, I will complete light waves, Ramya, and then I will start. There is one more lecture which is of Young's double slit experiment, and then I will do that. Yes, Vicky, I'm going to do ray optics also for 12th standard, all right? So let's get going. Are you all ready? Full of Josh? How many of you have already studied the chapter, honestly? Let me know, okay? And I have a question for you. In fact, I'm going to answer this question towards the end of the class. You will understand how this works. It's a very interesting problem. If I ask you to drink some juice from a straw, okay, if I ask you to drink some juice from a straw, let's say this is your container, this has some juice and there is some straw in it, and that is you, okay, that is Pandu or that is you, okay, and you're going to put this straw in your mouth. My question is, how high can this straw be? How high do you think this straw can be? Hello Kanishma, hello Madhav, welcome Karthik, hi Logesh, hi Molesh, welcome aboard. Okay, so some of you have not studied, no problem, it's okay. So this is a very interesting question. I'm going to ask you this now, but the answer for this will be disclosed towards the end of the class. So how high do you think you can elongate the straw so that you can still sip it without any, problems? Okay, Ramya saying 0.8 atm related pressure will be decide the height according to capacity. Okay, I'll give you one more option. You can suck it, stop, again suck it, stop. That's okay, you can hold the straw. You need not have to suck it in one go. You can suck it, stop it, relax, chill, yeah, breathe some air, and then again suck it, and again then press it. You can keep doing that. Then what is your answer? Then is it more than certain height? Can it be 3-storied building? Can it be 5-storied building? Can it be infinity? What do you guys say? Hello Ishpreet. Okay, it depends on atmospheric pressure. All right. So we're going to talk about it. I'm going to disclose the answer, somewhere in the session. So stay tuned. So I hope you have already smashed the like button. So now what is a fluid? So remember, a lot of people always think fluid means water. Water is just an example of fluid. Fluid is anything which flows. It could be gas, it could be liquid, but not solid because it cannot assume the shape of the container. So all the things which can assume the shape of the container and which can flow, they have very similar alike properties, and that's why we categorize them as fluids. Now you might be wondering, how exactly is this chapter going to flow in the Nurture series? So let me give you a small breakup. See, fluid mechanics is actually divided into, generally 3 categories. First is fluid statics. Hydro, fluid, yes, very similar. Statics means it will be stationary, it will be at rest. Okay, so we're going to see static fluids where things are floating, or you're finding the pressure in a container where the gas is at rest, something like that. Hydrodynamics. Dynamics means moving. So when fluids start flowing through capillaries, through tunnels, through canals, through pipes, so that is fluid dynamics. And then we have non-ideal fluids where you have certain non-ideal behavior like viscosity. Okay, yep. So when did I start fluid mechanics? Today is the first lecture, Lalitesh. Okay, yep. Thermo will be done after this. Yep. So now, yes, liquid disturbance will be talked about in hydrodynamics. The disturbance, the turbulence, we are going to talk about it briefly in hydrodynamics. Now, what categorizes? Like we have ideal student, right? So in a class full of students, right, you have somebody who is very ideal. An ideal student completes the homework on time. He sits on the first bench and maybe he answers all the questions asked by the teachers. And then, I don't know, he takes part in all the competitions. So probably this is what an ideal student looks like. So this is an ideal student. This is how he looks like, okay? So this is how an ideal student looks like. This is how it is. How many of you are ideal students? Please raise your hands. Now, what is an ideal fluid? What is an ideal fluid? Okay. Yes, Vicky, this is enough for everything. Yep, this is, once you study for JEE, you also study for CET, you also study for VIT, you also study for NEET, you also study for SRM, you also study for BITSAT, you also study for KVPY, you also study for blah, blah, blah. Okay. Now, well, great. Now, what are the characteristics of an ideal fluid? The characteristics of an ideal fluid look something like this. First of all, understand it cannot be compressed or expanded. Yep, it cannot be compressed or expanded. That's one assumption we generally make in most of the cases. So gases to certain degree will not be ideal because you can easily compress gases. So an ideal fluid, okay, so you cannot compress it, you cannot expand it. Okay, so you cannot compress it or expand it. So this is not allowed. Then understand one more thing, there is no viscosity. There is no viscosity. What is viscosity? Viscosity is not there. Honey, sauce, ketchup. Have you ever drank honey or have you used sauce or ketchup? How it is when you pour that sauce or ketchup? It hardly flows, right? It hardly flows. But if you have a bottle of water like this, if you have a bottle of water and you pour the water, it flows everywhere. It easily flows because it is less viscous. When the fluid is thick and there are a lot of drag forces, which take away that kinetic energy of the fluid, then it is a viscous fluid. I hope this is clear. Madhav used it just some time back. Correct, Madhav? Yep. So Newton, don't worry, the Canva results will be out. Hold on. Okay, very good. Sajad, now onwards the class timings are 7 o'clock. So viscosity is not there. There are no dissipative, there are no forces which take away the energy of that fluid. Then that is an ideal fluid. So viscosity is absent. And there are certain more characteristics like density will not change. I mean, that's obvious from this because, think about it. If it cannot be compressed or expanded, the density also won't change. I hope that is clear. Alright, Akash, join in, bacha. Even if you are a little bit late, it's okay. It's okay. Okay, very good, very good. And basically, it flows very easily. It flows, or basically it can slide. So this is something which is an ideal fluid. It slides and flows very easily. It can take the shape of the container. So that's what it is. Perfect. Okay. So what is the most important criteria that we are going to study in this particular segment of fluid mechanics? Like I told you, fluid mechanics is divided into 3 parts. We are first going to start with hydrostatics. And like I said, that statics means it is basically at rest. So what it means is, look at this liquid which is in this container. If I take any part of that fluid, so what is this? This is nothing but a system. This is nothing but a system. The net force on it should be how much? Come on, put it up in the chat box, my warriors. What do you think the answer should be? What do you think the answer should be? What do you think the answer should be? The net force should be. And what do you think the net torque should be? What do you think the net torque should be? It should be 0, and the net force should be also 0. Makes sense? Perfect, Harita. Good evening, Kalyani. Long time. Very good, Lalitesh. We will be doing at least one lecture and probably another class on Monday. Definitely, it will be 0. Net force is 0. Net torque is also 0. And this automatically means acceleration is 0. This automatically means alpha is 0. That means it is not translating. It is not rotating. Okay, so we do not study those things under the purview of hydrostatics. You will always see this will be obeyed. It will be almost at rest. It will be hardly moving. Great. So that's the first segment. Remember, after this, after 2 classes, we are going to start with hydrodynamics. Everybody, I think, is clear about this. Okay. So after 2 lectures, we're going to start with dynamics. Very good, my warriors. Perfecto. I can see all the zeros in the chat box. Now, there are some important properties that you should know about fluid. Now, everybody knows about density. So, although I have put up over here hydrostatic pressure, this is one of the important properties. So, when I talk about properties of fluids, everybody should know about this property, which is density. And everybody knows density is how closely packed it is. Generally, the symbol is rho, and it is nothing but mass by volume. Obviously, it is expressed in kg per meter cube. Now, you also have another, way of writing density, that is relative density. Relative density generally is also referred with respect to water. So, what is the density of water? The density of water is 1 gram per cc, that is in CGS, but you can also write it as 10 to the power 3 kg per meter cube. This is some standard value which you should remember. Density of water is 1000 kg per meter cube or 1 gram per cc. So relative density is nothing but density of that object upon density of the standard material that we usually choose, and that is also basically nothing but water. Sometimes it is also called as specific gravity. Specific gravity. Okay, so specific gravity talks about relative density. So guys, think about it. If I tell you the specific gravity is 1, if the specific gravity is 1, that means it's as dense as water. If the specific gravity is 1.3, if the specific gravity is 1.3, then what do you think will happen? Come on, put it up in the chat box. What do you think will happen if the specific gravity is 1.3? Come on, put it up. Come on. I know, Newton, you are very curious, but as soon as I find out something, I'll definitely put it up and reply to your comments. So what do you think will happen if specific gravity is 1.3? By common sense, by general knowledge, by your past experiences, what do you think will happen? Okay, so Dakshin, we are going to talk about that in thermal expansion. Okay, so we're going to talk about it, not now. Right, so what do you think will happen? Obviously, if the density is higher than that of water, then if you put such an object in liquid like water, it will sink. Yes, 1.3 is more than water, definitely it will definitely sink. And if it is less than 1, obviously it will float. Perfecto. That's one thing. Second thing is pressure. You always talk about pressure of a gas, pressure of a liquid. So you don't generally, talk about force by a liquid. There are cases where we discuss force, but generally we talk about a property called as pressure. And this pressure is nothing but the intensity of the force. What is it called? Intensity of force. Pressure is a word used only for fluids. You never talk about pressure for a solid. So fluids means both gas as well as liquid. So you only talk about pressure for liquids or gases. When I say intensity of force, it means force per meter square, force acting per unit area, and that means the unit of this will be Newton per meter square. You can also write basically Pascal. Okay, so ATM, all these are other units, and pressure is nothing but the force divided by area. But remember one thing, if the force is at an angle, then only choose the perpendicular component of the force. The parallel component of the force should not be considered. So whenever you write pressure is force by area, keep this in mind, it is perpendicular force divided by area. Fair enough, everyone? Clear about this? Shall we go ahead? Yep, very good, very good. Let's get moving. Everybody clear? Give me a thumbs up, give me a yo. All right, very good Alka, very good, excellent deduction. Moving ahead. So don't worry, you're going to get all the things in the PDF as well. So pressure is force by area. Now there are some interesting properties about pressure, and let's talk about it now. Okay, there are some interesting properties about pressure, and here it is. That is called as Pascal's law. One of the first things that you do when you wake up in the morning, and there could be many things, but one of the first things is you brush your teeth, and before you brush your teeth, you open the cap of your toothpaste and you squeeze it on one side, right? You squeeze it on one side and you have fun, especially when the toothpaste is about to be over. So just imagine this. This is your test tube. Which is your favorite toothpaste? I don't know. Which one is your favorite toothpaste? Hi Mohan. Hi Simple Girl. Good evening everyone. Okay. Chalo. So think about it. Okay, what's your favorite toothpaste? Let me just put up, I don't know, close up. Okay, close up. Okay, so that's your toothpaste and you squeeze it. You squeeze it on one side with your hands. Okay, this is your hand. This is the hand of Pandu. This is Pandu. He's trying to squeeze it. What happens? The fluid flows to the other side, right? It flows to the other side. And even if there is a cap, if you squeeze it on one side, even if the cap is there, the other side starts bulging. What has happened is basically any change in the pressure on one side of the compartment or the container immediately flows to the other side, because when you squeeze over here, the pressure increases. But here the pressure is low. So immediately the liquid will flow from high pressure to low pressure and it will try to equalize the pressure and the other side will bulge out. Correct? So basically what has happened is any changes in pressure in a closed container, that's very important, closed container. Because if the cap was open, imagine if the cap was open, you squeeze it, this won't bulge out, this will just come out. It will probably go stick on this wall. And then again you will get a flying slipper from your mother, correct? Because the toothpaste has just gone and stuck on the wall and then you have to clean it. So if it is closed, then you will see the pressure will adjust itself. Now this principle is called as Pascal's law and it is used in day-to-day life, and you will see a lot of phenomena based on Pascal's law. Pascal's law tells that whenever you change the pressure, it tries to adjust itself, it equalizes, it normalizes everywhere till the pressures on all the parts of the container, including the fluid, become the same. Yes, it tries to maintain that pressure. And one of the good example is right over here. Look at this. This is a piston. Look at this. This is a piston. Somebody is trying to push it. Somebody is trying to pressurize it. The moment you try to pressurize it over here, other parts of the container won't stay quiet. Other parts of the fluid won't stay quiet. What will happen? The moment you try to increase the pressure, everywhere the pressure will equalize it. Okay, so everywhere the pressure will increase and everywhere you will see the same pressure. So in a closed container, enclosed liquid, at equilibrium, the pressure change at one point is transmitted to all other points of the liquid till the pressure normalizes. Yes, we are going to solve problems. Now, one of the best examples is this one. How many of you have played with syringes in your bachpan, in your childhood? How many of you have played with syringes by connecting them? And how many of you have seen this in your car showroom or maybe your garage somewhere. This is very interesting phenomena. Very interesting phenomena. Thank you, Uma. This is very interesting. Look at this. Such a big, expensive, heavy car. Look at this guy. Who do you think is heavier? Pandu or car? Come on, put it up in the chat box. Simple Girl has played. Lalitesh has played. Who do you think is heavier? Pandu or the car? Who do you think is heavier? Okay, Roshni also has played. There are two objects. This is called as a hydraulic lift. Okay, car is heavier, obvious. You'll be like, sir, what are you saying? I mean, this is such an easy question. You are asking such obvious things. Obviously, car is heavier. But look at the interesting thing out here. The person, the Pandu standing over here, is able to lift the car. Why is it so? Why is this Pandu able to lift that car? Okay, let me just get the Pandu back. Okay, please, where is that Pandu? Oops, where is that Pandu going? Okay, there we have the Pandu. Let's get this Pandu. Okay, this is all because of Pascal's law. What does Pascal's law say? If any changes in pressure happen, it will get transmitted everywhere the pressure becomes equal. Correct? So, can I say the pressure of the piston or this piston, so basically pistons, is pressure on the pipe, is also the pressure of the fluid, is also the pressure on the walls of the container, that means the cylinder. Can I say this? How am I able to say this? This is only because of Pascal's law. Everybody agrees with this particular concept? Everybody agrees with this particular concept? Pressure of this piston, pressure on the liquid, pressure on the walls, pressure on the pipe, pressure on the cylinder, everything is same. It's normalizing it. Now, what is the pressure on the piston? See, this Pandu has some weight, correct? So, he is applying some force F1. So, what is F1? F1 is basically the weight of this particular Pandu. The weight of this particular Pandu. What is this F2? This F2 is nothing but the weight of that particular car. So, can I not say the pressure here and pressure here are equal? So, therefore, F1 by A1 is equal to F2 by A2. F1 by A1 is equal to F2 by A2. Now, just rearrange these terms and see what do you get. Just rearrange these terms. So, F1 by F2 will be A1 by A2. Now, out of A1, sorry, this is A1 and this is A2. A1 and A2, who is more? Out of A1 and A2, who is more? Obviously, we can see that A1 is less and A2 is more. If A1 is less and A2 is more, that also means F1 is less than F2. So that means what it means? That a small force can equalize a large force. A small force can balance a large force. That's all it means, and you can check by putting some values. For example, if this A1 is 1, A2 is let's say 100, then if F2 is 100 kg, then F1 can be 1 kg. Crazy, right? Here, if you put 1 kg mass, you can support 100 kg mass on this side because the area of cross section is 1:100. That's how fascinating this is. That's how fascinating this is. This is the best example of Pascal's law. Everybody has understood this. Can we now switch on to problems? Everybody, please give me a yo if you guys have got this. It looks very non-intuitive. So how is it possible? But this is how it works. The force per unit area is same. Not the force per unit area is same. Chalo, let's start doing some questions. Okay, so this is one good example out here. I have put it up in the PDF. Don't worry, you're going to get all of this. Okay, so I put it right over here, whatever I have done. Pascal's principle. Okay, come on, quickly answer this. Okay, Ramya, no bacha. For an ideal fluid, but I'm the father of all of you because you are my bacha log, maybe. Okay, for an ideal fluid, viscosity is absent, volume and density remains constant, bulk modulus is infinity, rigidity modulus is 0. Come on, what do you think it is? Yes, Nani aspirant, mechanical solids have been completed theory and basic problem wise, but you will have another problem solving session very soon. Problem solving session will be there on solids later on. Okay, Alka saying A. Okay, I'll give you one hint. More than one may be correct. More than one may be correct. Be careful. More than one. Ideal fluid. What are the characteristics? Think about it. Yes, I'm going to give you week-wise timetable. Selva Kamantan, tomorrow's class. Definitely. Yep. Yep. Okay. ACD, AB, D. Okay. Very interesting. And the correct answer is actually all of them, and all of you are wrong because all of them were correct. So, viscosity is absent. I just mentioned about viscosity. No drag forces, no losses, no loss. That is the characteristic of ideal fluid. Volume and density remains constant because it is not compressible. You cannot compress it. So it is not compressible. So this is also correct. Bulk modulus is infinity. This also comes from this. If bulk modulus is higher, then it means, because bulk modulus was 1 by compressibility, the compressibility is less. So if this goes to infinity, this goes to 0. So it is basically not compressible. Very, very important. And last thing, yes, unexpected twist, rigidity modulus. You're like, sir, what? Why is the rigidity modulus even coming over here? I'll tell you what rigidity modulus was all about. If you have forgotten, rigidity modulus was got to do with shear. Remember, this was nothing but shear modulus. And what is shear got to do with? It's got to do with sliding. So if you have layers of fluid, they can slide with respect to each other easily. If they can slide easily, they can shear, they can bend, they can take the shape very easily. And once things can slide, their shear modulus is less. If shear modulus is more, it's very difficult to slide one over the other. They won't bend. I hope you understand this. So hence it is 0. Another example for that would be, imagine, this is a book with lots of pages in it. If I apply a force like this, you can see the pages slide over it. There is some shear modulus. But if this was a liquid, all the layers will tuck, they will start sliding and they will flow and they will spread everywhere. So that's why shear modulus is basically 0. Perfect. What is bulk modulus? Kaluri, just watch my previous class. It's got to do with the property of the fluid related to compressibility. Previous class on properties, mechanical properties of solids. Watch it. Next question coming up on your screen. Alright, yes, velocity gradient creates that low rigidity modulus. Perfecto. Yep, Nani aspirant, I'm going to create a timetable for all of you tomorrow for 2022 warriors. And for 2023, I'm going to come up with another strategy session. Don't worry, stay tuned. In a fluid of bulk modulus B, density rho naught, if it is compressed by changing pressure delta P, then the new density is going to be. Interesting question. Bulk modulus is given, change in the pressure is given. What is the new density? Okay, so think about it. There is a liquid whose mass is m, volume is v. Okay, and there is some pressure acting on it, maybe. Okay, there is some pressure acting on it, maybe atmospheric pressure, whatever. Now what happens is you change the volume. So this was your initial volume or V naught. Now you change the volume. How? By applying some pressure and the volume decreases. This is your final volume. But even when the volume changes, what will remain same? Volume might get smaller because you have compressed it. Mass will remain same. It's the same mass. Correct? So that has happened because of change in the pressure. Fair enough. So let's go by the definition of bulk modulus and start doing the problem. What is bulk modulus? It is change in the pressure divided by negative sign, change in the volume upon original volume. Do you remember this? This was the formula. Yes, mass will remain same. Okay. Now, here is what will happen. Just take this delta V by V over here. So it will, and take this B over here. Let's see what happens. So because I want I want the new density. So delta V by V will be negative delta P by B. Now what is delta V? It's final volume minus initial volume, and this is also initial volume. V stands for initial volume, delta V stands for change in the volume. This is equal to minus delta P by B. Take this minus sign inside, so it will become V naught minus Vf divided by V naught is equal to delta P by B. Now just do a simple math. V naught by V naught is nothing but 1. This will become minus Vf by V naught is equal to delta P by B. Interesting. Once I get this, I can shift this guy over there, this guy over here. So it will become 1 minus delta P by B is equal to Vf by V naught. Okay. Now till here I have simplified. The only thing that I need to do is somehow convert volume into density. And I think I know what to do. Density initially is mass by volume. Final density, because the density would have changed, is same mass by that new volume, which is Vf, correct? So now think about it. Just substitute Vf over here and V naught from there. So what was Vf from there? Just check this out. What is Vf? Just from here, Vf is nothing but m by final density. Density goes below and Vf comes on the top. And what is V naught? V naught is again mass by initial density. You can just swap the terms and you can see that. Clearly what is happening? Mass goes off and you're just getting rho naught by rho. And this is nothing but 1 minus delta P by B. Swap the terms. Take rho on the top, take this below. So rho will be nothing but rho naught divided by 1 minus del P by B. So I think that's our final result. I have got what I wanted. This is initial density, this is change in the pressure, this is bulk modulus. This gives me the final density. Very interesting problem, and it is very important problem. There were questions in mains, advanced, BITSAT so many times on this particular concept. Is that clear? Just check this out. So what we did, initial mass, initial density, initial volume, final mass, final density, final volume. Mass remains same. Go by the definition of bulk modulus. Bulk stress by bulk strain. This was the formula I just gave you few days back. That negative sign comes because you have to always keep it positive and all of that. Just rearrange it. It's just pure maths after this, basic algebra, which anybody can do. Okay, perfecto. Let's get moving. And here is the answer, rho naught by 1 minus delta P by B. Okay, here is the next question on Pascal's law. This was asked in February 2021, previous year question. Let's see how many of you, if you are giving the JEE 2021 exam in February, how many of you can actually crack this? There is a hydraulic press, the same. What is this hydraulic press? Exactly the same diagram. This diagram over here. There's a hydraulic press, hydraulics. Okay, that's what you should visualize. Where it can lift 100 kg when a mass m kg is placed on the smaller piston. It can lift how many kgs when the diameter of the larger piston is increased 4 times and that of the smaller piston is decreased by 4 times, keeping m on the smaller piston same. Very interesting. Let me give you a time for solving this. Within 1 minute you are supposed to solve this. Let's see if you can solve this within 1 minute. I've started the timer now. Okay, so I'll just draw the diagram for you. So this was the smaller piston right over here. This is the tube, okay, and this is the bigger piston right over here. Perfecto. And yep, you had that mass m over here, and over here you had basically a different mass. So earlier this was 100 kg. Now if you change the areas as mentioned, what do you think will be the new load that you can lift? That's the question. Come on, my warriors, figure this out. Hardly few more seconds remaining. Do the math quickly in your rough books. I'm pretty sure you can crack it within the stipulated time. Come on, 10 seconds to go. Figure this out. Come on, my warriors. Think. Alrighty, the time is up. The time is up. Now let's calculate this. In Pascal's law, I told you, using Pascal's law, I told you pressure at point 1 will be pressure at point 2. Pressure at point 1 will be mg divided by smaller area. Here the area will be smaller and here the area will be larger. Okay, and on pressure at point 2 will be that force will be whatever 100 G divided by that larger area. Anyways, G gets cancelled. Now is the nice trick. Mass is the same, only we need to figure out what will happen with this 100. Okay, here is one simple trick. What I'm going to do, keep that 100 as it is, take that A over here. So M, capital A by small a is equal to 100. Now this 100 is nothing but your old weight which can be lifted, Now see what is happening. The diameter of the larger piston is changed 4 times. If you recollect, area is basically pi r square, which is pi, r is diameter by 2, so it will be diameter square by 4. So can you see that the area is actually proportional to the square of the diameter? It's proportional to the square of the diameter. So think, if larger piston's diameter is increased 4 times, so the area will increase 4 square times, which is nothing but 16 times. Do you agree with this? Capital A will increase 16 times. What about small a, my warriors? What about small a? Smaller piston is decreased 4 times. So if the diameter decreases 4 times, the area will become 1 by 4 square times, which is 1 by 16 times. Agreed with this? It will become 1 by 16 times. Koi baat nahi Divya, just join in. You have missed some part, but you can always go back and you can always catch up. Hence, think about it. Numerator has become 16 times. Denominator has become 1 by 16 times. So totally as a ratio, how many times has it become? 16 into 16. How much is 16 into 16? 256 times. 256 times, everybody agrees? So LHS became how many times? 256 times. So RHS, how many times should it become? RHS should also become 256 times. So what is 256 into 100? 25600. Divya, we are doing fluid mechanics, fluid statics. That's the first part, and today we are doing Pascal's law and then hydrostatic pressure, barometer, manometer. Okay, so don't worry, we're going to complete this hydrostatics part in today's and Monday's class. All right, join in. I just completed Pascal's law. Okay, and now we are going to go to hydrostatic pressure. All right, cool, amazing. Go moving ahead to the next one. What a brilliant question. Yes, Satya, I can see your chat. Definitely. Mission IIT is our last year series. This year we are going to have different series, Ramya. Okay. Now let me also tell you, whatever I am teaching you, the questions, etc. will be available to all of you in the Telegram channel. The link is there in the description box. So do not forget to join it, because all important announcements and PDFs are shared over there. And remember, all those of you who want to join Vedantu and who want to cover up their backlogs, there is still an opportunity, a window of opportunity is there for all of you, because there is a crash course starting specially for 11th standard students. So go ahead, check out the link in the description box for 2023. There is a pro subscription link. I'll show that to you towards the end of the class. So stay tuned. Okay. So now let's talk about some more things about hydrostatic pressure. Now, what is this hydrostatic pressure? I'll tell you. Hi Jairam, welcome. Very good, Gaurav. Now, here it is. See, imagine, I'll tell you a simple story. Imagine there is a Pandu. Okay, there is a Pandu. He's carrying a book on his head like this. He's carrying a burden, right? If he's carrying a book on his head, what is he carrying? He's carrying a burden, right? Now, just imagine a Pandu like this, and you ask him to carry more and more books. There will be more and more burden on his head, and he will probably disappear. Great. Very glad, Nanda. Okay. Now, imagine even you guys, even me, I am carrying a burden, you are carrying a burden, but not of books, but of something else. You might be wondering, sir, which burden am I carrying, sir? That is something which is not seen by you, but it is there. Even right now, you are carrying that burden. That is basically the weight of the air above you. And this extends till wherever that atmosphere is. So this is where the atmosphere ends, and the entire column of air, all that air above you, is responsible for creating that pressure over you. Exactly. Now I'll be like, oh my God, this is breaking news, sir. I need to get rid of this pressure. So what Pandu does, he starts running for his life. He starts running. He's like, I don't want this burden over my head. He starts running and he takes shelter under a roof. And this Pandu now becomes very, very happy. This Pandu becomes now very, very happy. He's like, yes, hooray. I don't have that burden of this atmosphere because the only amount of air above me is this much. So now the burden on me is less. Do you think this Pandu is correct or wrong? What do you guys say? What do you guys say? What do you guys say? This Pandu who ran away to escape the burden of the weight of the air supported over his head, he ran under a roof, under a shelter. He's like, okay, now I do not have that burden anymore. What do you guys say? Is he correct or is he wrong? Come on, my warriors, think about it. You too are under a roof, I'm pretty sure, unless you're watching this lecture right in the open in some garden. What do you guys say? What do you think? Is Pandu right in thinking about this, or is he wrong? Do you think he has escaped the burden? Do you think he has not escaped the burden? Come on, put it up. You could be wrong. It's okay. Nobody's judging you. What do you think? Is he wrong? Is he correct? Has he escaped the burden or not? Well. The answer is no, right, not escaped, says Nanda. Okay, Dakshin says no. The answer is he has not escaped the burden. You'll be like, what? Why didn't Pandu escape the burden, sir? Because there is a shelter. The shelter will prevent the weight of the air. You guys forgot that there is air besides as well. There is air besides as well. And it extends till infinity. So this burden is there. You'll be like, okay, so that will fall over here. It will not affect this. Think again. Think again. If this part has, for example, low pressure, this part, example, has high pressure, what will happen? Liquid will flow. Pascal's law, liquid will flow from high pressure to low pressure, tuck, and it will immediately increase the pressure. So you technically can't escape it. Even right now, over your head, you might be thinking, sir, only this much air is there. But don't forget, there is some air gap somewhere inside your room. There is some way the air from outside is escaping inside, and that's the reason why that pressure which was there outside has got transmitted inside, and that's why you indirectly have the burden of the air which is, outside the room as well. So basically what has happened is this, imagine another Pandu over here, this Pandu over here, both of them will have the same burden, because assume that you are assuming that this has low pressure. Just assume. Then this Pandu has high pressure, this Pandu has low pressure. So what will air do? It will start flowing. But remember, air should not flow. Why? Because we are discussing which topic? Hydrostatics. So basically this cannot be at low pressure, this cannot be at high pressure. Both the pressures should be same. That means both the Pandus will have the same amount of pressure. That's what it is. Is that now understood? Is that now clear, my warriors? Got it? So you cannot escape. No matter where you are, you cannot escape the burden of the air column above you. This burden of that air column is called as hydrostatic pressure. So this is the burden of the fluid, in this case basically the atmosphere column, and it is created because of gravity. Gravity is responsible for that particular weight. So gravity creates the weight, and that weight creates the burden. You cannot escape it. Now Vivek is asking a very interesting question. Sir, what if the room is packed with doors? Very interesting question, Vivek. Tell me one thing. Before packing the room with doors, wasn't the door open? So the air has already escaped. So already the pressure inside is the same as the pressure outside. Got it? So you cannot escape it unless you go out in space. You become an astronaut, you go outside in space, and then you remove all the air inside, and then you pack the doors, you pack the windows, you make it airtight, and then again come back from space onto Earth, and then outside and inside the pressure will be different. That's a different story because you have not allowed the air to enter inside in the first place. Is that clear, my warriors? Perfect question asked by Vivek. Okay, now, like I was telling you before, that pressure is always the perpendicular force by area. So in a fluid which has pressure, look at this container. It has some liquid and there is some body inside that liquid. That body could be floating, sinking, doesn't matter. The point over here is there is pressure everywhere. There is pressure here, there is pressure here, there is pressure here, because it's under the influence of gravity. There is pressure everywhere and it always acts in all the directions. The pressure will act in all the directions. So the moment it finds a surface, it will act perpendicular to it. So if you take a surface here, it will act perpendicular to it. If you take a surface here, it will act perpendicular to it. If you take a surface here, it will act perpendicular to it. So the pressure acts in all the directions and the force due to the pressure is always perpendicular to the area. Got it? So it's always perpendicular to that surface area and it always acts in all the directions and it's same. Okay? So that's what it is. Let's do some interesting derivation. Horizontal variation and very good, Vivek, and vertical variation. Variation of pressure with, horizontal and variation of pressure with vertical distance. There is a very interesting thing which happens. If there is a liquid and you move horizontally, then you will find that the pressure here, pressure there and pressure there will all be the same. Why? There is a very simple explanation. Imagine Pandu 1, imagine Pandu 2, imagine Pandu 3. This is Pandu 1, Pandu 3, Pandu 2 and Pandu 3. Come on. Imagine the burden on them. Imagine the burden of air column over them. What do you think? Will the burden be same or not when they are at the same height? What do you think? Will 1 be equal to 2 be equal to 3? Will 1 be more than 2 more than 3? And imagine another Pandu over here, which is, let's say, Pandu 4. Okay, what do you think about that guy's burden? What do you think about that guy's burden? And imagine another Pandu 5. Another Pandu 5. Think logically about the burden of the air column. It's very obvious. 1 will be equal to 2 will be equal to 3. 4 will be equal to 5. But 1, 2, 3 burden will be less than 4 and 5. Makes sense? Because 4 and 5 are at same level, so they should have the same burden, same pressure. 1, 2, 3 are at the same level, so same pressure, but 4 and 5 are deeper inside, so more pressure. So what happens is, when you move horizontally, the burden, the weight of the air column remains the same, so there is no change in pressure. So only when you change height, only then there is variation in pressure. Also keep this in mind, this is a more general rule. Actually, better word for horizontal is, here in this case when gravity is down, then in a direction which is perpendicular to gravity, in a direction which is perpendicular to gravity, pressure is same. So just imagine, for some reason gravity is at an angle. Gravity is at an angle. Do you think the pressure will be same along this line, line number 1, or do you think the pressure will be same along this line, line number 2, which is perpendicular? What do you guys say? What do you guys say? Come on, think about it. Yes, Kalka Kitchen, definitely. Okay, come on, think. Come on, think. What do you think? Will the pressure be same on line number 1 or will the pressure be same on line number 2? Think. Yes, because, yes, very good, Roshni. Yep. So people with height have less burden. Yes, Vivek, but the burden change will be hardly anything because pressure variations are very small for that height. It has to go by large heights for changing that pressure. Yeah. So line 2 will have basically the same pressure. Keep this in mind. They will have the same pressure. It's always perpendicular. Yep. Perfecto. Line 2 will have. This will not have. Keep this in mind. So that's the variation of pressure with horizontal. Now let's talk about the variation of pressure with height. Now we all saw that as you go in the direction of gravity. So what should I put? In the direction of gravity, the pressure, should I put increases or decreases? Come on. In the direction of gravity, should the pressure increase or decrease? Come on, quickly put it up in the chat box. Quickly put it up in the chat box. In the direction of gravity, that means you go down, down, down. So when you go down, 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 should the pressure increase or decrease? So as you go down, there is more burden. And if there is more burden, it should increase. So definitely it should increase. The best way to calculate that is by taking an element of the fluid, and I'll just mark this height as, let's say, dH. Okay, so dH is the element of the fluid, okay, which I have taken. It's a cylindrical element. I hope you can see that. The top area over here is A. The bottom area is also A. Pressure, let's say on the top, forget this. Pressure on the top, let's say, is different, and on the bottom also it is different. So let's say at the bottom it is P, okay, at the bottom it is P, and at the top it is P plus dP. P plus dP. dP is the small change in the pressure. Bottom it is P, as you go up dP change. It's the change in the pressure. Now the force acting on the bottom and the force acting from the top will be P plus dP into A and P into A, because pressure is force by area. So force will be pressure into area. So pressure into area is force, pressure into area is force. So from the top there is more force, from the bottom there is less force. Like, sir, this is wrong. You said the net force should be 0. So how is it possible from the top there is more force, from bottom there is less force? Guys, the answer is simple. You missed out on one more force. Think about it. So that one more force is nothing but the gravity. One more force is nothing but the gravity. Yes, weight. So you should also show the weight of it. The weight of it will be also there. And how much will be that weight? The weight will be, think, mass into gravity. But the mass, think about it, it will be mass into gravity. The mass is given by density into volume. Density into volume. Density is rho. Volume of that cylinder. Calculate the volume of that cylinder. It will be area of cross section into the height, which is dH, and gravity is nothing but G. So that's what it is. That's what it is. Now just use the concept that it is a hydrostatic fluid. Hydrostatic fluid means net force will be 0. I know some of you are still wondering, sir, 1 minute, something is wrong. Weight is down. Larger force is also down. Smaller forces on the top. Does not make sense. Guys, think dP will be actually a negative value. Yeah, dP is negative, but I just put it as, lower height P, a higher height P plus dP. Don't worry, it will automatically turn out. You will see when I solve the problem. Net force will be 0. So the forces from the top will be P plus dP into A. P plus dP into A plus the weight. What is the weight? It is rho A dH into G will be equal to force from the bottom. How much it is? PA. Now, can you see P into A and P into A will get cancelled? So only thing remaining is dP into A plus rho A dH G is equal to 0. Shift this over there, but before that, do one small favor, cancel this A also. So just shift this over there. So what will you get? You will get dP is equal to minus rho G dH. Shift dH below. So dP by dH is equal to minus rho G. Now this is a very important relationship which you should know. What is this dP by dH? This is called as the pressure gradient with respect to or with height. Okay, pressure gradient with height. This is the most important formula, pressure gradient with height. What does this mean? It tells you what is the rate of change of pressure. dP is change in pressure with respect to height. My height changes by 1 centimeter, how much does my pressure change by? And that comes out to be minus rho g. Why is this minus coming out over here? The reason why this minus comes is because the pressure does not increase with height, it decreases with height. So this minus signifies the pressure decreases with height. That's the reason for that. As the height increases, the pressure decreases. As simple as that. Very good. Pranayam, Remu, I hope you get well and I hope everything is fine. I mean, I hope you have got your medicines and please take care, bacha. Please take care. I hope everything is recovered very soon. Yep. Okay. So, no problems. Even if you are late, you can always replay the session and start from the beginning and catch up to wherever we are. All right. Very good. So, this is what it is. dP by dH is called pressure gradient. Minus because the pressure decreases with height. Rho and g is the density and gravity at that place. Perfecto. Now, using this you can calculate the pressure at any depth h. So we can just do that pressure variation, inside a fluid. Okay. So by the way, do you know the value of something called as the atmospheric pressure? This P0 is also called as the atmospheric pressure that has been mentioned over here. The approximate value, although the exact value is 1.012 into 10 to the power 5 Pascal, you can approximately take it as 10 to the power 5 Pascals for most of the calculations. Okay. Hi NV18. Hello motivator, welcome aboard. Very good. Now, the next thing is, what is the pressure at any depth? We know at the sea level, what is this P0? P0 is called as the atmospheric pressure. When you go inside the liquid, then the pressure will change, correct? The pressure will change. That pressure variation with height can be derived from dP by dH. I leave that up to you. So using this relationship and integrating with proper limits, what you get is pressure at any depth is the pressure at the fluid level, which is exposed to the atmosphere, plus rho g h. That's exactly what you get. And if you are wondering what this h is nothing but the depth inside the liquid surface. How deep are you in? Is that understood? Perfecto. Hi Ravish. Yes, and Vedantu is good for everything. NEET, Olympiads, JEE, everything. Hi Bharat. Yep. So that's what it is. Cool. So remember this formula P0 plus rho gh. What is P0? P0 is the atmospheric pressure. A rough value, remember it. 10 to the power 5 Pascals. Rho, density of that liquid. G, gravity. H is the height or depth inside this liquid. Yes, Mangalam. Obviously, we are doing more than CBSE. It will be obviously useful for CBSE once you prepare for JEE. Alright. So guys, remember one thing. Now onwards, my timings of the class will be 7 p.m. onwards. Okay, 7 p.m. onwards. So please make changes. Now onwards, it is 7. So that we finish our classes somewhere around 8:30, 8:45. You also get a break and Shimon sir's class starts at 9. So all of that. So we can also have longer lectures. That's another interesting thing that happens because of the change. Cool. No problem, PBX. I'm so glad that at least you watched the recordings. That's good, and I'm pretty sure you will have a different experience today just because you're attending it live. Alright, now this hydrostatic paradox. Very interesting thing. Now, let me give you a brief about this. So just imagine a situation where there is a pipe which is bent in certain manner. Okay, that pipe is bent into certain manner. Now here, which is this part which is exposed to the atmosphere, that has atmospheric pressure P0. Okay, this is exposed to the atmosphere. So basically this is nothing but your atmospheric pressure. There is liquid inside this. Okay, there is liquid inside this of density rho. You see that there is a tank here, it could be any random shape, and there is a point X, and at that point X I am asking you to find the pressure. That point X is at a depth h below this level. What do you think the answer will be? Will it depend on the shape of that container, shape of that pipe? Think about it. I just mentioned the pressure at any point only depends on the depth. It does not change with horizontal level, right? In the same liquid, if you go from one point to the other point to the next point, you will not see any variations. That means it should not matter what is the shape, only the height should matter. So this should be just P0 plus rho GH. It should be just P0 plus rho GH. Correct? Makes sense. Hi Q Takansha, welcome. Welcome Tamil. Hello. So this means that if I have multiple containers, one big, one small, one wide, one narrow, one of some random shape, doesn't matter the shape, the size of the container. What should happen is that irrespective of the shape, irrespective of the size, irrespective of how bent it is, as long as they are connected to each other, all the containers should have the liquid till the same level. All the containers should have the liquid till the same level. Yes, that means the pressure at this point, pressure at this point, pressure at this point, pressure at this point should all be equal. Yes, it will be more than P0, but they will all be equal. They will all be equal. And the reason why they should be equal, this, why should they be equal? Think, if they are not equal, imagine a situation, just imagine, if they are not equal, then what will happen? There will be pressure difference, and the moment there is pressure difference, what will happen? The liquid will start flowing from high pressure to low pressure. So if there is high pressure here, low pressure here, immediately the liquid will flow and they will equalize it. So they will start flowing till there is equal amount of height in all the containers. Glad to know that, Sarvana. Excelente. And don't worry, all the 12th standard warriors, all the 12th standard students, don't worry, we are going to start our remaining portions immediately after your chemistry exam. So stay tuned, and tomorrow there is a special class just for all of you, on how to strategize for the JEE 2022 exam. So this is called as hydrostatic paradox. Paradox because a lot of people think that depending on the shape and the size, the liquid level will adjust. Bigger container will have maybe more fluid or less height. No, it doesn't work that way. It only depends on the height, nothing else. Independent of the area, independent of the shape. Okay, here are the questions coming up on your screen. Okay, Bharat, I think it should be there, Bacha. I'm not sure. It should be there. It should be starting somewhere around 8 o'clock. Why the dam water reservoir is thick at the bottom? What do you think? Welcome, Money. Welcome. Okay, nice name. Money. Paisa. Okay. NV18 saying C, Alka saying C, Roshni also saying C. No, Ansh Dubey, modern physics is yet to be done in the Pathfinder series. I am just doing light waves. I just did 2 classes. I'll do more 2 classes and then we'll go to modern physics. Hold on, stay tuned. I'm going to do everything. I remember everything. I've made a promise, and tomorrow I'm going to announce something special, even for 2023 students. It's going to be very interesting. So attend that class. It's going to be very interesting because there is some series launch which I'm going to do tomorrow. Spread the word, spread it everywhere. For 12th standard, for 11th standard, that there is something new coming up for specially, revision and increasing your level in your board examination and JEE Mains examination and JEE Advanced. Okay, all of you are saying C. Yes, the correct answer is C. If you have seen the cross section of a dam, it looks like this. And the reason is very obvious, because here the pressure is P0. So atmospheric pressure will act perpendicular to the surface of the wall. As you go below, the pressure increases, 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 increases. So more force here. So if there is more force over here, that's why to hold it, you need a thicker wall. So the pressure increases, that's why the force increases, and that's why, you know, the dam should be wider. Here is the next question. This was asked in March 2021 PYQ question. How many of you are going to crack this question? Let's see. This is a PYQ. Okay, let's see how many of you can crack this. The pressure acting on a submarine. Wow, 3 into 10 to the power 5 Pascal at a certain depth. Now the depth is doubled. You go deeper. The percentage increase in the pressure acting on the submarine would be G is 10, density is 1000, atmospheric pressure is 10 to the power 5 Pascals. Let's draw the diagram. Vishal, why was you not going to Mysore? So sad, no? Yes. Please ask Shimon sir why he did not carry me to Mysore. I am very angry with Shimon sir. He did not take me to Mysore. I am very angry. Ask Shimon sir. Everybody should spam in today's class or tomorrow's class whenever Shimon sir is going to take. Why you did not take Shreyas sir? Spam. You guys have to make this promise. Okay, cool. Thank you, Bharat. It means a lot, and it means a lot because you came here and said that thank you too. All the best, bacha. Stay tuned. There is a special announcement tomorrow for all the 12th standard students. So be there at 11 o'clock in the morning on Sunday. Interesting. Now what do we have over here is that at certain depth h, the pressure is 3 into 10 to the power 5. Interesting. Now if you double the depth, you have gone to 2h, then what is that new pressure? That's what the, sorry, not the new pressure, what's the percentage change in the pressure? Alright, here is my logic. See, when you are here, right, then 3 into 10 to the power 5 will be P naught. P naught is the pressure over here, right? Okay, plus rho GH, correct? It will be P naught plus rho GH, fair enough. Now, think P naught is nothing but 10 to the power 5. We already know that. Atmospheric pressure is just 10 to the power 5 plus rho GH. So basically, rho GH, take the 10 to the power 5 here. Take that 10 to the power 5 here. What will it become? 3 minus 1, 2. 2 into 10 to the power 5 Pascals. Perfect. Now, let's talk about this point. For that point, the pressure will be again P naught plus rho G, but 2H. P naught is 10 to the power 5. 2 comes as it is. What is rho GH? Rho GH is 2 into 10 to the power 5. So 2 into 2, 4. 4 plus 1, 5. So 5 into 10 to the power 5 Pascals. That's what you got the pressure as. But the question demands to find the change in the pressure, percentage change. Ramanaya saying option A, Dakshin saying okay. Oh, option A, let's see. So percentage change in the pressure will be final pressure 5 into 10 to the power 5 minus initial pressure 3 into 10 to the power 5 divided by initial pressure, which was again 3 into 10 to the power 5 into 100 into 100. 10 to the power 5, 10 to the power 5, 10 to the power 5 gone. 5 minus 3 guys, 2. 2 by 3 into 100. 2 into 100, 200 by 3 percentage. Is it there? Yes, it is. Some of you got those marks. Very good, Mani. Very good, Dakshin, Harita. Excellent, my warriors. Very good. Arey bacha, don't worry, RMKesh. You got 28 marks. You stay with me till the end. Term 2 and JEE, you see what happens. Just have trust on me. Imagine just in the last few days, if it could make such a big difference, staying with me for the next 3-4 months till your JEE, till your boards is going to make a hell lot of difference. And I saw all your lovely comments which you guys posted in my sessions in the last few days. So I'm always there for you, and it's also something for your juniors, 11th standard kids. So guys, remember Shreyas sir is always there. It's not a journey for one lecture. You have not come over here for one lecture. You have come here for 2 years. You have come here for 3 years maybe, or 4 years. depending on which standard you are in and watching this video. So this is a long-term journey. This is not a 40 minutes, 1 hour, 1.5 hour class. It's a long journey. It's a bond that you're going to have with me for years, because you're going to treasure this and you're going to enjoy this and you're going to remember this when you enter into IITs. Remember that. Alright, let's get moving to the next one coming up on your screen. Here it is. Hello Nishant, welcome aboard. If the pressure at half the depth of a lake is 2/3 the pressure at bottom of the lake, what is the depth of the lake? Let's see if you can solve this question in 1 minute. Meanwhile, I'll start drinking water. Here we go. Write equations. Even if you're watching this lecture in a recorded form, it's okay. Pause the video. Think how we can do this. At half the depth of the lake is 2/3 the pressure at the bottom of the lake. Assume the depth of the lake to be h or h/2 or something like that, and then start solving. Eliminate the options, and I'll give you a hint. Take atmospheric pressure as 10 to the power 5. Take density of water as 1000. Take G as 10. G is standard 10. Density is 1000. Atmospheric pressure 10 to the power 5. That's it. Use it. It will help you. Only then you'll get the answer. Come on. Let's see how many of you can do this question. 10 seconds to go. Dun, ta-da. Let's see how many of you can do this. 5, 4, 3, 2, and there we go. Time is up. Oops. Looks like not many people could make this, but okay, let's solve this together. What do we do? So we have the liquid surface. Let's say we go down. The pressure at half the depth is equal to 2/3 the pressure at the bottom of the lake. So what will you do, guys? First you will start assuming, right? So let's just assume the depth of the lake to be h. So this is at h/2. The pressure over here is, let's say, P1, and at a depth of h, let's say the pressure is P2. Okay, so this is basically at the bottom. This is basically the surface of the liquid. Now, according to the question, the pressure at half the depth, that means here, P1 is 2/3 of the pressure at the bottom of the lake. That means P2. That's what the question means. So understanding the statement and making the equation is what you should develop. That art is something which you should slowly develop. That's a skill. That's the statement. You created an equation. Now what is P1? Try to remember the formula. Pressure at depth h. So P0 is the pressure over here, right? On the surface. So P1 is nothing but P0 plus rho g, but not h. H is height or the depth, which is h/2. This is 2/3. Pressure at that depth will be again P0 plus rho g just h. Fair enough. What do you do next? Cross multiply. Take that 3 over here. So 3 P0 plus 3/2 rho g h is equal to 2 P0 plus 2 rho g h. 3, 2, yes, cancel. Can you see that here and here? Take that 2 P0 here. So it will just become P0. Take this dude over here. So it will become 2 minus 3/2 times of rho g h. Interesting. 2 minus 1.5 is 0.5. 0.5 is half. So this is just going to be rho g h by 2 is P0. But what is the question? The question is the depth of the lake. So what is being asked? H is being asked. So H will be 2 times of P0 by rho g. Substitute. P0 is 10 to the power 5. Your rho is 10 to the power 3. G is 10. 1, 2, 3, 4 zeros. 5 zeros. So 1 0 remaining with a 2. So that's going to be 2 into 10, which is 20 meters. That's it. That's it. Done, done, done. It looked difficult. But it is easy. It looked difficult. It's just a matter of making the equation and solving it. Do not give up. Have patience. That's all. Have patience. Got it? Shall we move ahead to the next part? Perfecto. Yep, there we go. Option B is correct. Interesting. Now, we're going to talk about a special device. And in fact, there are two devices. That is called as a barometer and manometer. Baro, mano. What does baro do? And what does mano do? Now, I'm pretty sure you would have done this in the bathroom, and do not lie about this. What would you have done? There could be many things, but this is one of the crazy things you could do in the bathroom. That is taking a mug, inverting it, and then dipping it inside the water. It's upside down. Upside down. And then you try to lift that mug above the surface of the liquid. How many of you have tried doing this? How many of you have tried lifting? Fill that mug completely with water, put it, immerse it completely inside the water, and then try to lift it up. If you have not done it, do it right now. Leave water, quickly, run towards the bathroom, leave that water, immerse a mug, and completely fill it with water, and try to lift it upside down. Just try to do this. Okay, come on, think. What has happened? What does your experience say? What does your experience say? What has happened? You would have experienced a lot of difficulty in taking that out. Yep, you would have definitely experienced a lot of difficulty. Now the mug is not so tall, but imagine you had a tall test tube. You had a tall mug, and that entire mug or the tube can be immersed in water, and you slowly take it out. You slowly take it out. You will see that the water will gush inside that tube. It's going to, Dakshin, if no water has come out, that something has gone wrong out here. Maybe there is a leakage, some gap is there, some air has gone inside. If air goes inside, then it will not come up. So make sure that there is no air inside. Yeah, it's going to be a little tricky, but you can try it out. You see, if you take a tube and if you pull it, the water will go inside, but that does not mean if you keep pulling the tube, the water will just continuously keep on going up. No, that's not what's going to happen. There comes a point where even if you pull the tube beyond a certain point, certain extent, you will see the water will not fill the tube completely. It's not going to go till here. You will see there will be kind of a vacuum created there. There will be kind of vacuum. Yes, it's like something was pulling the mug back into the water. What is pulling that mug back into the water? If you cannot feel it, you will not understand it. And you have to feel it by going to the bathroom. That's your homework. That's your try at home experiment. Very rarely you get such kind of homework. I'm a crazy physics teacher, ain't I? So what happens is basically this water is what you're holding. When you try to hold the mug, what's happening is this vacuum is created. That vacuum is trying to pull it, and basically you are trying to hold this water which is stuck because of that vacuum. So when you try to pull the tube, indirectly via that vacuum you are trying to hold that water, and lifting that water is a pain. So it's like the water is pulling you down because of its own weight. Because of its own weight. That's what is happening. Now there is a limit till which it can go, and that limit is, let's say, height h. Fair enough. Now what's exactly happening? Let's say the water reaches this height. So this is your height, not this one. Okay, not this one. Just ignore this. There's a vacuum created over here. We all know this is fluid at rest. In a fluid, in a fluid at rest, what should happen? Everything, net force should be 0, pressure at same height, should be same, correct? Pressure at same height should be same. Now look at all the points over here. There's one interesting thing that is happening. This point, 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 all are at the same height. So shouldn't the pressure be equal? Shouldn't the pressure be equal? Come on, my warriors, what do you guys say? It should be, right? So can I not say that the pressure at point A and the pressure at point B should be equal? Pressure at point A and pressure at point B should be equal, correct? So if the pressure at point A and pressure at point B is equal, think what is the pressure at point A? Guys, pressure at point A is open to the atmosphere. So what is the pressure at point A? It is just the atmospheric pressure. It is just the atmospheric pressure. Correct? Next, what is the pressure at point B? Oh, wait a minute. It is inside a liquid. So it will be pressure at this point plus rho GH. Pressure at this point plus rho GH. Think again. What do you think is the pressure at this point? This is vacuum. There is nothing there. So the pressure over there is 0. It's 0. Correct? No, it will not be greater than atmosphere. It will be equal to. You are on the surface. You are not inside. You are on the surface of the liquid. So it will be equal. So think about it. It will be nothing but 0 plus rho GH. Why is this 0? Because there is vacuum over there. Got it? Now think about this. If I rearrange this, I will get H is equal to P naught by rho G. Now this is a very interesting equation because if you put the exact values like 1.01 into 10 to the power 5 and rho you put it as for mercury. Mercury is 13.6 times heavier than water. Yes, it is 13.6 times heavier than water. It's a metal. It's a very, very heavy metal. It's in the liquid form. If you take liquid mercury, that's 13.6 into 10 to the power 3 into G. G is 9.8. If you put the exact values and all of that, guess what? This is going to come out to be 0.76 meters. Okay. So if you're wondering what this 13.6 is, this is basically density of mercury. Density of mercury. Now, you might be wondering, wait, 0.76, it's a very familiar number. What is 0.76? 0.76 meters is 76 centimeters. That's right. You can see that right over here. Yes, Arul, you can definitely watch it. 76 centimeters. And that's nothing but the unit of pressure. So that's where it comes from. So essentially, 1 atmospheric pressure is 76 centimeters when you fill a barometer with mercury. So 76 centimeters of Hg. That's where the unit comes from. Exactly, Dakshin. Even I had the same doubt, and your doubt will be clarified in the next question. There's a question which is going to come up on the screen, and that will definitely, clarify your doubt. Hold on. Is that clear how this unit of pressure came? 1 atm is equal to 76 or 760 millimeters of Hg. That's the same thing. So what is barometer used for? A barometer is used to measure atmospheric pressure. What is it used for? It is used for measuring atmospheric pressure. Keep this in mind. Perfecto. Shall we go to some questions? And here it comes on your screen. And by the way, I have put all the theory right over here. All right. Here it comes. If water is used instead of mercury in the tube, what is the length of the water column in the tube if the tube is very long? Assume the tube is very long. What do you think? If instead some guy decides, some maniac decides, okay, I'm not going to use mercury. I don't have mercury. I want to use water. Fair enough. How much do you think the height of that column will be approximately? Approximately. Make some suitable assumptions and do this. Come on, my warriors, figure this out. It's not that crazy. What is the formula we just learned? We learned P naught is equal to rho GH for a barometer. For a barometer. P naught is roughly 10 to the power 5. Density is 10 to the power 3. G is 10. I know over there I had taken 9.8 and 1.01 and all of that. Yeah, it's okay. Fair enough assumptions. Into height. So guess what this height comes out to be? Approximately as 10 meters. Oh my God. Oh my God. 10 meters. Do you know what's the height of your room? Do you know what's the height of your room? Around 4 meters, 3 meters, around that. 10 meters. It's like a 2-story building. Goodness, will you have a 2-story long test tube as a barometer? Obviously not. You're going to break it. You cannot handle it. You cannot handle a 10 centimeter test tube. What are you going to handle? A 2-story test tube. You cannot. It's practically not feasible. It's not good to have such a long test tube. So that's why you use a denser liquid. Is that clear? Everyone got it? Perfecto. Moving on to the next question. Okay. Yes. Is H constant? Very interesting question. Is this H constant? Well, this H is constant only if the outside pressure is constant. If the pressure changes, then H will change. Sometimes you go to a hill station. If you go to a hill station, guys, come on, what will happen? If you go to a hill station, what will happen to this H? What will happen to this H? Will this H go down or will this H go up? You take this barometer, you take this device, pack it in your bag and take it to a hill station. What do you think? Will this H decrease or increase? Come on. Oh, Tarun, my subject is, I talk about hills and geography and hill stations. So I'm a traveler and that's my subject. So I'm teaching how to travel to the hills using barometer. That's what I teach. Yeah. Pahadi, they usually call this subject as Pahadi subject. Alright. So decrease, yes, perfect. It will not increase. So as you go up in the atmosphere, the pressure decreases. So the pressure decreases, this will decrease. If this will decrease, H will decrease. If pressure decreases, H will also decrease. That's it. As simple as that. Got it? Okay, I have another question for you. Just imagine, you put this barometer in one lift. You put this barometer in a lift. Now, the lift starts accelerating upwards. It starts accelerating upwards. Inside you have your normal air. Okay, inside you have normal air. What do you think will happen to this H? Yes, JEE Advanced, you have to study deeply for JEE Mains. What an irony. Wow, we have JEE Advanced here. Interesting. Very good. Congratulations. So, if it accelerates upwards, what do you think will happen? Yes, NV18. What happens is, if you look at this equation, P is equal to rho GH. G will no longer remain G, it will become G plus A. That means this has increased. That means H has decreased. So it will decrease. It will decrease. It will not remain constant. The air is the same. The air is the same. There is no change. The air is still the same. It will be P naught. But you will see less than 76. So imagine a Pandu inside this lift. Look at this Pandu. He's thinking, what the hell? I should actually see 76, but he will see 74 centimeters instead of 76 centimeter. What will this Pandu think inside the lift? What do you think? Will this Pandu visualize or conclude in this lift by looking at the barometer? He will see instead of 76, it's showing 74. He will think, oh, the pressure has decreased. But actually, has the pressure decreased? Think about that. The actually pressure has not decreased. That's the funny part. Have you understood this? Pandu will feel inside this lift, the pressure has gone down. But strictly speaking, it's just what he's perceiving. But actually it has not. Actually the pressure, the air is the same. It's just that the reading shown is less. So that's an error in that measurement. Do you guys get it? Everyone got it? Perfecto. Let's get moving to the next question. But before that, I think we have manometer. Manometers. What does a manometer do? This is like a U-tube. That's it. U-tube. Like the one you're watching right now. No, not that one. This is U-shaped tube. U-shaped tube. So what's a manometer got to do? Look at this. Very interesting device. You take a U-tube. Okay. And you pour some liquid. Okay. Now, if you just take a U-tube and you pour some liquid, so what will happen, my warriors? The liquid will be same in both the arms. This is the arm of U-tube. This is the arm of the U-tube. The liquid inside will be of the same height. The liquid will be of the same height. Why is the liquid till the same height? Because the pressure from here, both are same. So there is no reason why the height should be different. Rainwind Raptor. द प्रॉब्लम इज बच्चा, दिस इज एन इंग्लिश चैनल. मेरे को हिंदी अच्छे से आती है, बट क्या है कि ये इंग्लिश चैनल है, अपने पास एक बढ़िया सा इंग्लिश चैनल भी है वेदांतु के पास. सो वी हैव ऑल काइंड्स ऑफ चैनल्स. सो I would request you to go watch it there. But yes, if you are an English medium student, you should definitely watch it over here. But imagine somebody increases the pressure, more pressure over here. It will push the liquid down, it will push the liquid up here. So, if there is some chamber, if there is some container which has some gas or liquid, then what will happen is that this high pressure will push that liquid down and that liquid will go up, and that creates the height difference. And using this height difference, you can find out what is the pressure difference on both sides. Don't believe me? Check this out. Check this out. Do you guys agree this is the same liquid and at the same height the pressure should be same? So this point and this point, same pressure. This point and this point, same pressure. This point and this point, also same pressure. So, okay, pressure is same at same horizontal level in the same liquid. So I can just say PA is equal to PB. What is PA? A is exposed to the gas over here. So this is basically the pressure of that particular gas, because A is directly exposed to the gas. What is pressure at point B? It is deep inside this liquid, and at this point it has atmospheric pressure. So it is P atm plus rho gh. So interesting thing is P gas minus P atm divided by rho g, divided by rho g is what you get over here. Very interesting. Very interesting. Okay. Yes, definitely calm killer. Hi Siva. What is this? This is nothing but delta P. This is rho g and this is h. This has a very interesting formula. This is called as the gauge pressure. This is called as the gauge pressure. Gauge pressure tells you how much is the difference of the actual pressure as compared to the atmospheric pressure. For example, imagine, just for an example, the pressure of the gas is 1.2 atm and the atmospheric pressure is, let's say at that location is 0.9 atm. Possible, right? Possible. You are on a hill station. So the gauge pressure is basically 0.3 atm. This is kind of an excess pressure. How much more than the atmosphere? Do you know one interesting fact, that when you fill air in the tube of your vehicle tires, which pressure do you measure? When you fill air in the tube of your vehicle tires, which pressure do you actually measure? Yes, gauge pressure can be negative also. It can be negative, it can be zero. The pressure that you always refer to is the gauge pressure. Why gauge pressure? Because every place might have different pressure. Somebody might be staying at the hill, somebody might be staying near the sea, somebody might be staying near a hurricane, somebody might be staying in some random location. So everywhere there could be different climate. So to standardize it, we define relatively. So if the atmospheric pressure is this much, you need to have this much excess pressure. That's it, it's a standard. So you always talk with respect to the atmospheric pressure. That's what is used to fill the air in the tubes of your vehicle tires. Very important. Perfectly. Yep. I don't know where you guys say. Alright, so here we have a question right up on your screen. Two immiscible. Immiscible means they do not mix, like oil and water. Yep. But Fanta and Coke, that is miscible. Okay, so two immiscible liquids having different densities are filled in a U-tube as shown. Comment on the pressure at A, B, C, D, E, F. Look at this. This is a different liquid. This is a different liquid. Come on, what do you guys think? Is that's it? That's a manometer. So what does a manometer do? It measures gauge pressure. What does a barometer do? Actual pressure. Keep this in your head. Baro measures actual atmospheric pressure. Mano measures difference of the pressure, the relative pressure. That's it. Okay. Okay, so what do you guys think? Oh, no. Comment means which one is more, which one is less. So pressure at point A, pressure at point B, pressure at point C, pressure at point D, pressure at point E, pressure at point F. What symbol should I put over here? More, less, equal to? That's what the question is. It's not about C and D. What should I put for, let's say, E and F or A and B? Now, the logic for solving immiscible liquid problems. Remember this? I'm teaching you a trick. So what is the trick? Whenever you see, okay, immiscible liquids in a YouTube, what you should do? Start, this is the trick, start from bottom. What you should do? Always start from bottom. Very, very important. Because when you start from the bottom, you generally will find the same liquid over here. Do you see the same liquid? This light greenish color liquid, and it's the same liquid, so the pressure should be same. So E and F should definitely have the same pressure, obviously. As you go up in this liquid, this point, same pressure, this point, same pressure, this point, same pressure, this also same pressure, this also same pressure. C and D, yes, we are technically still inside the light green liquid, so C and D should also have the same pressure. Got it, my warriors? Perfect. Now comes the problem. As soon as you go up over here, here is the problem. Yeah. See, you are going in a different liquid, here you are going in a different liquid. That is the problem, my warriors. So here the pressures won't be equal. That's very important in spite of being at the same level. So a lot of people think just because 2 points are at the same level, the pressure should be equal. That is incorrect, my dear warriors. The pressures are equal at the same height if it is in the same fluid. The fluid is the same here, C, D, E, F. That's why they are equal. But A and B, nah, they are not equal. Got it? So that's the condition. A lot of people make that mistake. I wanted you to point out this to you. Okay. Now the question is a numerical one, a similar concept. Two immiscible liquids, heights are mentioned. The blue one is density ρ2, the green one is density ρ1. The common line also has been drawn. Question is, find the ratio of the densities. Yep. Does it have to be of the same vessel? Basically, I am me. Oh my God, what is this? I am me. The thing is, it should be a continuous liquid. Doesn't matter whether it's same vessel or not. Even if the vessels are different, as long as there is a pipe connecting it, if you have a connecting path, then it works. Okay, perfecto. Let's have a look at this now. Two immiscible liquids are there and the densities are given. The question is, what is ρ1 by ρ2? We know that this point A and this point B will have the same pressure just from the previous logic. So pressure at point A will be pressure at point B because this point and this point are in the same liquid. At this point, the pressure will be, assuming atmospheric pressure to be P0, it will be nothing but P0 plus rho, which is ρ2, into G. Okay, G is G. H is 4H. Fair enough. Pressure at point B will be again P0 plus rho is ρ1, G is G, H is 2H. Interesting thing. P0 goes. Wow. G also goes. Wow. H also goes. Wow. So 4 ρ2 is equal to 2 ρ1. So ρ1 by ρ2 is 4 by 2, which is 2 by 1, which is just 2. Done. Yes, NV18. Perfecto. Gauge pressure, Abhishek, it means the pressure difference between pressure in a container minus outside or atmospheric pressure. So the difference of the pressure inside the container minus the pressure outside or atmospheric, the difference is called as the gauge pressure. So all those of you are joining in late, make sure that you watch the complete class after this. Okay, that's it. Very good, calm killer. That's the spirit. That's how you should help all the new warriors who are joining in. And yes, thanks a lot for smashing that subscribe button, and thanks a lot for also loving this video and helping us grow. It means a lot when you hit that like and you hit that subscribe button. There we go. Find the force on the bottom surface of a container due to the liquid, neglect atmospheric pressure, density is rho. Look at this container. Do you see height h, width w, length l? There is a liquid filled till this much point. What's the force on the base? So we are shifting to the forces on the walls of the container. Should we take ATM pressure always? Yes, definitely. Always it will come. Okay. Now here the question says find the force due to the liquid. So this liquid will apply some force on the base of the container. This is how the base of the container will look like, and there will be obviously some pressure over there, so it will be exerting some force definitely on it. Correct? That force, the force on the base, can be written down as pressure on the base into the area of the base. Now when I write pressure on the base, there is one small catch. Many students make a mistake. Pressure on the base is not P naught plus rho GH. It is just rho GH. Why? Because it says due to liquid. Only due to liquid. See, if the container was empty, anyways the base would experience P naught. Agreed? If the container was empty, on the base air would still exert that force. So when you pour that liquid, that extra force comes because of whom? It comes because of the liquid. So because of the liquid, it is just rho GH. Got it, my warriors? Got it, my warriors? Perfecto. Into area. What is the area of the base? W into L. That's it. Rho GH W L. Do we have it? Yes, we have it in option C. Perfect, AB, Arjun. Done, dana, done. Very good. Now we have a slightly modified question. What is this? Find the force on one of the side walls due to the liquid. Side walls. That's the catch. Side walls. Okay. I'm not going to look at the options. It's not needed. Let's just solve it independently. Side wall could be something like this over here. I'm just going to mark this over here. Okay. This is the side wall. On this, because anyways the air is there on the top, liquid is only there at the bottom, so only this much part is going to experience force. Now I have a problem. You know what my problem is? No? You don't know what my problem is? My problem is I cannot say force on the wall is pressure into area. Like, sir, why? The pressure is not same. Why is the pressure not same? Yeah, the pressure will change with depth, right? So pressure is different. So over here, the force will be less, pressure is less. At the bottom, the pressure will be more. And as you go deeper and deeper, the force is going to increase, the pressure is going to increase. So it is going to be a varying diagram. So the force will be different at different places, like you see over here. Correct? It's something like that, like how the dam's shape is wider at the base. So that means I need to account for the variation of pressure. So what I'm going to do, I'm going to divide it into small strips. Yep, no viscosity and all. We have to just divide it into small strips. So let me just consider a strip right over here. Okay, so imagine a strip right over here. Okay, just going to assume this as a strip. So imagine this is the strip that I have chosen. On that strip, everywhere the pressure is same because it is at the same horizontal level. That strip, okay, it's at the same horizontal level, so the pressure is same. So I think I can calculate the force on that strip, and I have multiple such strips right from the top to the bottom. If I add all the forces on all such strips, if I add the forces on this, all the strips, I will get the total force on the net container's wall. Yes, Roshni, you got it, integration. So I first need the force on the strip. I just need the force on the strip. The strip force will be the pressure near that strip into area of the strip. Interesting. I don't know any values, let's just assume certain values. Like, for example, let's just say this is depth, let's say x. If that is x, this width will be dx. Are you getting it? If that is x, that is dx. If this is y, that is dy. So that's how it works. Okay, x is the depth, dx is the width. This is the length of the strip. So think, what should be the area of the strip? What should be the area of the strip? The width is dx, length is L, so it should be L into dx. Do you get that? Y is the area, height into the length. That's it. Fair enough, all my warriors, perfecto. Shall we go ahead? Now, what is the pressure at that strip? Due to the liquid only. Don't take into account, because it just says due to liquid. Don't take into account the atmospheric pressure. Hi Sundar. So it is just going to be rho gx. Rho gx. Rho g depth. No p naught over there. That's it. So this is the force on the strip, and since it's not just F, it will be dF. Why this d came? Because it's a small teeny mini force on a small strip. There are many such strips. So the net force on the vertical wall is basically the sum of forces on all the strips. That means it is integration of dF. That means it is integration of these guys, rho gx L dx. Okay, let me just shoo these people away who are constants, like rho, g and L are constants. X dx, I need to integrate with respect to x. How does x vary? Look at this, the strip starts from the topmost point. The strip starts from the topmost point. So x is 0, and the last strip that you take is at the bottom. It is at the depth of h. So the first strip is when x is 0. The last strip is when x is h. What is the integration of x dx? X raised to 1. Integration is x raised to 1 plus 1 by 1 plus 1. X raised to 1 plus 1 is x raised to 2. 1 plus 1, 2. And the limits are 0 and h. So therefore, the net force will be, I'm just going to do it over here. It is rho g L, and you will have h square by 2 minus 0 square by 2. That's how you do the integration, right? This is definite integration. You put h over here, then you put 0 over here, and then subtract both of them. So this is just going to be rho gl h square by 2. This is the force acting on the wall. Rho gl h square by 2. What a brilliant question. Perfecto, Srishti. Very good, Roshni. Excellente, Arjun. You guys got the limits. So that's how you involve integration as well in fluids, and that's the answer, option A. Now I have posted some homework questions just for you. So you have to post all the answers in the comment section. I'm going to read all the names next time. So this is the first homework question. Do not forget to solve and post it ASAP. Oops, the answer should not be shown. Oh my God, why was the answer shown? Ignore. Okay, I cannot help it now. Now, there's a very special announcement. In fact, I have two announcements for all of you. Okay. One of the announcement is the announcement of an announcement which is going to happen tomorrow. So yes, I'm going to announce certain interesting things. And yes, there is something in store for even the 11th standard students. So do not forget to watch and share the video and recommend, your friends, your seniors, as well, your batchmates to come tomorrow at 11 o'clock, Sunday. Yeah. A special short announcement session along with strategy. Now, also, there is a course which is started on 6th of December. This is for all the 11th students. Now, in this course, your 11th syllabus, right from beginning, like for example, vectors, sets, whatever, mole concept, all PCM, okay, PCM, all the subjects, the entire syllabus will be completed. in the next few months. Okay, it's in the next few months, and immediately after that, what is going to happen? Your 12th syllabus will start, and it will continue obviously till the end in October, November, whatever. And yes, you're going to have tests, you're going to have mock tests, you're going to have assignments, all of this, revision plan. After this you're going to have revision being planned, everything. And not just that, you are also going to get on this beautiful mobile device of yours, you are going to get my courses too. Yep, you're going to get my courses like HC Verma course, Rodov course, derivation course, and yes, you're also going to get problem solving course. So problem solving course as well. All of this is going to get, you're going to get, in this particular course. You might be wondering, what is this course called, sir? This is called as the Vedantu's Pro subscription. Obviously, you get live teaching, like I said, assignments, tests, report cards. You will also have regular, improvement sessions with your master teachers, with special experts, strategy and tip sessions. And this will continue till the end of JEE Advanced 2023. And yes, this is in English. And also my micro courses. Now, if you're wondering, sir, okay, this is interesting, I want to check it out. How do you check this out? Very simple. You might be watching the video right now, and what you need to do is just go down. Just go down over here. Okay, so this is my video. Just go over here, go to the description box. Avail exciting Vedantu courses, JEE 2 years. Click on this link. That's it, it will open 2021 to 2023. Now it's 2021, you're targeting 2023, right? If you want to change it over here, you can definitely change it to some other thing. You can see topic specific short courses, revision, other courses, regular JEE. Also your CBSE examination stuff is covered over here. No need to join any other classes. KVPY is also included. Yep, all the things. You can also get the replays if you miss a class. That's the advantage. No need to waste time traveling, needless to say. And there are 3 packages: Lite, Classic and Plus. In Lite, you get everything whatever I said. In Classic, you also get doubt solving on your mobile app. You have any doubts, just ask our doubt experts, they will answer you. And in the Plus version, what you get is basically the personal mentorship. So you will also have dedicated personal teachers to help resolve all your important academic queries like how should I plan, how should I study, okay, I'm demotivated, okay, what should I do in the next few days. They will make schedules, they will help you out. That's personal guidance. Most of the students go for the Classic version, and many students start off with the Lite and they eventually migrate to Classic or Plus. So I would suggest, if you want, you can definitely try out the Lite version. It's just 1,350 rupees. Yes, that's right, 1,350 for 15 days, but you also get additional 15 days on this trial just because you use my coupon code. This is only valid with my coupon code, SHHPRO. And if you want, you can also buy the entire course. You again get discounts on the entire courses when you hit the buy button. You can see you save like thousands of rupees. You have saved 6,750 rupees just by using my coupon code. You have multiple options like credit, debit, Amazon, even you can opt for EMI options, and it comes to hardly 3,000 rupees per month. That's how it works. So I would be really looking forward to all of you, because you will be joining my courses as well at prices as low as 1,350 rupees, 1,800 rupees and 2,700 rupees. These are much more affordable than your regular coaching centers. Thank you guys very much for being here. Do not forget to post all the answers in the comment section. I'll be reading out all the names next time. And remember, stay tuned for the term 2 syllabus. Yep, because we have to eventually target the JEE 2023. Get your friends. See you again and again at 7 o'clock. That's my new timing. Thank you very much for liking and sharing and also hitting the subscribe button. You can also get in touch with me on my Instagram handle, Shreyas_Vedantu. Take care. Bye-bye, Nivi. Bye-bye, Calm Killer. Roshni, take care. Bye-bye, Septimus Heap. Take care, everyone. Have a great time. Dakshin. Have a lovely time. Stay safe. Stay cool, stay calm, and keep studying. Bye-bye, Abhishek. Take care. Good night, bachalo. This was your Capto Shreyas signing off. Bye-bye. Hasta la vista.